This is a very short, but also an extremely important section. We just talked about ionic materials, and that's electron transfer. But when electron transfer is not favorable, what you're going to have is electron sharing. And electron sharing is another way to talk about covalent bonding. So when we have the hydrogen molecule, what we have is each hydrogen is a 1s1. There's just a single electron. And what can happen is when they share electrons, they can form a bond. It's now the S is totally full. We'll talk about those models in chapter 9. But here we show one hydrogen atom, another hydrogen atom. Here we have them sharing their electrons. And what we can do is we can represent that by a line. So when you see a structure, like you've seen them before in molecules in chapter 2, that line meant there was a shared pair of electrons. So you're going to be looking at the Lewis structures for molecules. And you're going to be learning how to use what is called the Octet Rule. Let's say I have unshared electrons. Remember, oxygen had 6. And unshared pairs, they are shown as dots. I may show it in this way. I normally circle it as I teach. They are also called lone pairs, and they're also called non-bonding pairs. So that's the vocab for this section. What else do we have here? Well, let's just show an example. You learned that chlorine was a diatomic molecule. Now let's tell you why it happened, okay? Chlorine is a neon core, and it has 7 valence electrons. So if I take my pre-drawn letters, there's one chlorine. Here is another chlorine with 7 valence electrons. When those two chlorines come together, what they have, each of them now has 8 electrons around it. By that I mean there are 8 here, and there are 8 here. Each of them has 8 electrons, otherwise known as an octet. That will result in a stable molecule. Now, you will have to draw these when you take organic chemistry. Organic chemistry doesn't have multiple choice questions. Organic chemistry has short answer questions, so it's kind of no getting around guessing. You have to write down exactly what the answer is. The TA's working for that. They spend like a whole day grading. They get breakfast, lunch, and dinner. It's a very long grading session. But that would be our Lewis structure for a chlorine molecule. And notice, that's where the Cl2 came from. Each chlorine has an octet of electrons. So that's a diatomic. And the other one I want to show you is HCl, the molecule. All right? Hydrogen is a 1s1. It has 1 valence electron. Chlorine has the neon core. And then it has in its N=3 shell 7 valence electrons. So here we have our hydrogen. Here we have our chlorine, and notice, you don't have to put the dots on the same side. I'm just going to say that. What'll happen is there will be a shared pair in between the two. Now, hydrogen has 2 electrons. That's all it's ever going to have because it's very small. And now the chlorine atom has 8 electrons. Again, very, very, very straightforward. And if you are struggling with this, please don't move on until this is crystal clear. It's going to get a lot more complicated, okay? What else do we have here? Well, this is my trio. This is water and ammonia and methane. And I'll kind of show you what I mean as we go through it. We have 2 hydrogen atoms. Each of them has 1 electron. We have an oxygen that has 6 electrons. So if I bring them together, I will have oxygen having 8 electrons, and my hydrogens will each have 2 electrons in its shell. The actual Lewis structure, I would draw it like this. where these are my lone pairs. And you will see me do this throughout this course because I am an organic chemist. And it's those lone pair of electrons that do a lot of chemistry when we talk about organic chemistry. That is the Lewis structure for water, the water that comes out of the faucet, okay? Next is the Lewis structure for ammonia, NH3. We have 3 hydrogen atoms that each have 1 electron. And what we have is a nitrogen atom that has 5 valence electrons. And maybe you see how I drew it. There is a lone pair of electrons, but then hydrogen donates 1, nitrogen donates 1. Hydrogen donates 1, nitrogen donates 1. Each of them is going to donate 1 to make the covalent bond. And what we need for our correct Lewis structure is to designate that pair of electrons, all right? So I call this kind of the trio because if you can kind of see a pattern, so far the molecules I have, I'll call it 4 electron domains. I don't mean to get ahead of myself. But here we have 2 bonding, 2 non-bonding. Here we have 3 bonding and 1 non-bonding. And let's kind of move on to methane. This is the same gas that comes out of a gas stove when you cook. We have 4 hydrogen atoms. We have 1 carbon atom that has 4 valence electrons. You probably know where I'm going. I have my 4 electrons that come from carbon. I have an electron that comes from each hydrogen. And there we have it. Carbon has an octet. Each hydrogen has 2. I replace my 2 electrons by actual bonds. This is the Lewis structure where I have 4 bonds. Now, what is this stuff I'm writing? Well, if you had VSEPR in high school, you will learn that that is the technique we use to finally predict a molecular 3D geometry. No sense hiding it from you here, okay? So where did I get this? This water has 2 bonds, and it has two non-bonding pairs. Ammonia has 3 bonds, and it has 1 non-bonding pair. Methane has 4 bonds, and it has just 4 bonds. That's all that it has. I mention this also because if you're a bio person, many of the molecules in our bodies have carbon, hydrogen, nitrogen, and oxygen. So you're going to see this an awful lot. The other thing I'm going to say is there's a model called hybridization that's coming up in the next chapter. And if you understand this, it'll make that a heck of a lot easier. Now, what's on the last slide? Well, it's what I had by mistake on the one before. And I just left it, okay? I want to have an octet when I'm having a covalent bond. So maybe I'm going to have 1 bond between the same 2 atoms, but to get that octet, maybe I have to have more than 1 bond. So essentially, here are some examples. We're going to go deeper into how we draw them in the next section, but for now, we know oxygen has 5 electrons. We know carbon has 4 electrons, and what's going to result, and we'll talk about this in the upcoming sections, is the following molecule. CO2, carbon dioxide, you're currently exhaling it. This double bond indicates we have 2 shared pairs of electrons. Take a look. What we have are 8 around an oxygen. We have 8 around a carbon. We have 8 more around an oxygen. When we are sharing 2 pairs of electrons, we write it with 2 lines. That is called a double bond, okay? Another type of bond, so that's our double bond, and you can probably almost guess where I'm going with this. This is called a triple bond, and that's where you're sharing 3 electron pairs. You might say, I don't care, but guess what? The air you're breathing, the majority gas in there is nitrogen, okay? So as I draw my structure for nitrogen, what it's going to be is each nitrogen has 5 valence electrons, and what you'll learn in the next section is how we rearrange that, but what we get is a triple bond for nitrogen. Let me kind of write that here also. I can't seem to make that work. I would have 2 electrons on one side of the nitrogen, Then I would have all of those in the middle, but notice how each nitrogen has an octet, and 3 shared pairs of electrons gives us a triple bond. Oh, I should have written them this way. That would make more sense. So again, we will be teaching how to do this, but what I wanted to show here is that I will result in a final Lewis structure that satisfies the octet rule. And that is going to be our next section. It is going to, no, the next section is actually bond polarity. So kind of like a minefield. Anyway, that's it for this section.